and welcome to trigonometry. My name's Ms. Taylor and I'm going to be your teacher today. We're going to go over chapter 1. We're going to do section 1 and section 2 just to maybe reteach it to you so you'll do better on your next quiz. Okay, let's begin. Miss Taylor, what is a radian? Good question, Lakin. A radian is the unit of measure that we will be using throughout the course, so it's very important to understand what it is. Okay, let me show you with this example. If the length of the radius is equal to the arc length, then you have a radian. So see here, our arc length is 2 inches, and our radius is also 2 inches, so this is the perfect example of a radian. It is time to say sayonara, toodaloo to degrees. In this next example, I have a full circle, which you know equals 360 degrees. From now on, we're just going to say that it equals 2 pi. 2 pi, where are you getting 2 pi from? Okay, let me see here. Now 360, you know if you split that in 2, you're going to get 180, and 180 equals pi. So it's easy as that. So you have, since 180 times 2 equals 360, you have 2 pi. And then when you take out half of that, you're just going to get the pi, obviously. Which it'll be like 1 pi, but you never really put that 1 in front of there. And then half of 180, you're going to get 90. Now there's no special symbol for 90 degrees. It's just going to end up being pi over 2. See, 90 over 180 equals 1/2. It's the exact same thing. Discovering quadrants. Take out a sheet of paper and draw this example. Make a lowercase t in the middle of your sheet of paper, and then draw the letter C in the middle of your graph. When you start at the top, when you're drawing the C, you're going to hit up quadrant 1, and then you're going to curve around and find yourself in quadrant 2. And if you keep on drawing the C, you're going to find yourself in quadrant 3, and then you're going to end at quadrant 4. Finding positive coterminal angles. Simply add 2 pi. Here's your example. 5 pi over 6 plus 2 pi equals 17 pi over 6 radians. Simplified, this would be 5 pi over 6, and then of course you have to find a common denominator, which will make the 2 pi equivalent to 12 pi over 6, because 12 pi over 6 equals 2 pi. So let's start over. 5 pi over 6 plus 12 pi over 6 equals 17 pi over 6 radians. To find negative coterminal angles, simply do the opposite. Subtract 2 pi. Here's your example. 5 pi over 6 minus 2 pi equals negative 7 pi over 6 radians. Simplified, again, all you have to do is find the common denominators. Let's try it one more time. 5 pi over 6 minus 12 pi over 6, because again, once you find the common denominators, 2 pi will equal 12 pi over 6. So 5 pi over 6 minus 12 pi over 6 will get you negative 7 pi over 6. Complementary angles. When you dress to the 9s, you get complements. 9, 90, 90 degrees. Complementary angles equal 90 degrees. Now let's find the complement of pi over 4. Remember, pi over 2 equals 90 degrees. Complementary angles equal 90 degrees. So let's see. Pi over 4 plus the unknown, or x, equals pi over 2. Find your common denominators, and pi over 2 will magically transform into 2 pi over 4. Now subtract the original pi over 4 from the problem from that 2 pi over 4, and you will get a remaining pi over 4, and that is your complement. Think of supper time when dealing with supplementary angles. Supper is an important part of every day. It's the final meal, which should last you until 6 a.m., so approximately 12 hours. It has to be big. Supplementary angles equal 180 degrees, which is half of a full circle. That is big. Now let's find the supplement of pi over 4. Remember, pi equals 180 degrees. Pi minus pi over 4 equals 4 pi over 4 minus pi over 4, which is 3 pi over 4. What I did, of course, like I did last time with the complementary angles, is found the common denominator, which is 4. 4 pi over 4 is equivalent to just plain old pi, so then I put that into the problem, subtracted pi over 4, and got my final answer. So the supplement of pi over 4 is 3 pi over 4. Now let's learn how to convert radians to degrees. The problem is 7 pi over 4, and 7 pi over 4 is already in radians, so now all you have to do is make a proportion, which will switch it over to degrees. At the top of your proportion, you're going to find 180 degrees, and at the bottom is what you want to take away. So let's see, you already have radians, so you want to take away the radians and make it solely degrees. So all you do is you just cross out radian, you cross out the pi, and you cross out the radians, which will leave you with 7 times 180 degrees all over the denominator, the original denominator, which is 4. You're going to multiply that problem, and that's going to give you 1260. And don't forget that you still have to divide by 4. And your total is going to be 315 degrees. But make sure that you add your degree sign, because Miss Gallo takes points off if you don't. Because, like I said earlier in the video, the new unit of measure that you'll be using for the majority of the class is radians. So she's going to assume that it's radians, and the whole point is to take away the radians, so that would just prove that you don't understand what you're doing. Now let's try converting degrees to radians. Let's start with this problem. We have 210 degrees. Now convert the degrees to radians. This time around, the 180 degrees is going to be at the bottom as your denominator. Why, you might ask? Well, because you want to take out the degrees. Last time, when we were converting radians to degrees, you wanted the radians to leave. This time, say goodbye to degrees once again. That's going to leave you with 210 times pi radians, divided by the denominator, which is 180 degrees. Actually, it's no longer degrees, excuse me. Now it's just 180, because we crossed out our degrees at the beginning of the problem. This answer simplified, which is the only way Miss Gallo will take it, will end up being 7 pi over 6, and the unit of measure is radians.